Welcome to part two of Volumes of Solids of Revolution. In the second part, this is the second part, and in the second part, I'm going to uh, actually solve quite a few problems. For example, the first problem that I'll solve is this one. I'll show you exactly how to work this out. But before I do this, let me do a quick recap of what we did in part one because we're going to need all that information here. Okay, the first thing is if we were to take a thin rectangle that looks like this and spin it about this line of revolution, we get a washer. And the volume of the washer is pi times rho squared, this formula, rho squared minus ri squared times t, right? R sub I is the distance from the line of revolution to the closest point on the rectangle, and R sub O is the distance from the line of revolution to the farthest point on the rectangle. So that means we can know precisely what R sub I and R sub O are. And the T is the thickness that you see. Remember this one. In a similar way, if we have a rectangle that is oriented this way, and that is spun about this line of revolution, then that would produce a shell, and the volume of the shell is given by 2 pi r L T. We have to be crystal clear about what in the world do we mean by R, L, and T. Keep that in mind, please. R is the distance from the line of revolution to any point in the rectangle, okay? And T is the thickness of the rectangle itself. L, or probably I called it H in my problems. So L or H would be the height of the rectangle or the length of the rectangle, okay? Now, please pay attention to this very, very important point. What's the difference between this and this? The first scenario and the second scenario. Here I said washer shell. And the key thing is, notice the relative orientation of the rectangle with respect to the line of revolution. When the rectangle is perpendicular to the line of revolution, you get a washer. On the other hand, when the rectangle is parallel to the line of revolution, you get a shell. That is the key part. Keep that in mind and let's get busy. So, here we have the area enclosed between the parabola and the straight line, this area, is spun about this line of revolution y equals -1, and we are supposed to figure out what the volume of that resulting solid is. And the first order of business in these things is, again, just as in area between curves, if you have watched my video on that one, you will see this. We need to first draw a rectangle, a representative rectangle. The question is, should the rectangle be vertical or horizontal? I explained earlier that it must be vertical in this case. So the first order of business is draw that rectangle and immediately show that it is at a distance of x from the origin, or in this case, the y-axis, either one is same, and that its width, the rectangle's width itself is dx. Okay? Then you have to decide which method are we going to use, the disk washer method or the shell method. One of the very last things I said in the previous slide is, if the relative orientation, that is the rectangle's orientation with respect to the line of revolution, is that it's perpendicular like here, automatically you're going to use the disk washer system, right? So, disk washer method, what is the formula for the volume of the disk washer? Pi times rho square minus ri square times t. Now that volume of that single disk washer is now going to be what is called the differential volume dV. Meaning, if just this rectangle alone were to be spun about the line of revolution, you get a volume. That is only the differential volume. If we want to find the total volume, we are going to scoot this rectangle all the way from left to the right, and each time you collect the volume, the differential volume, and you add up all those volumes together, which is the same thing as saying that we are going to integrate from A to B. A is the left end and B is the right end. We are going to integrate all the way from A to B this quantity dV. When you integrate dV, you would get V. When you integrate dV from A to B, you get the volume enclosed from x equals A to x equals B. As simple as that. So the key is to recognize that since the rectangle is perpendicular to the line of revolution, we have a washer. And immediately the formula for the washer's volume is pi times RO square minus RI square times T. And now, what are RO and RI? That is, if we identify that, we are in business. R sub I is the distance from the line of revolution to the closest point on the rectangle. So that's why I drew this line segment, because this is R sub I. Line of revolution to the closest point on the rectangle. And the line of revolution to the farthest point on the rectangle, which is that one. And that distance from the line of revolution to that point is R sub O. Okay. Now the question is, can we figure out exactly what R sub O and R sub I and R sub O are? Well, for starters, A is definitely 0. At this point, the x value is 0. And B is 4. The x coordinate at this point, the right hand point, is 4. R sub O is a vertical dimension. So the best way to get this is, please pay attention to this part. The best way to figure out R sub O is, because we are measuring this distance vertically, the y value at the top point minus the y value at the bottom point. That's it. So now the question is, what is the y value at this top point? Everywhere, all along this line, would you agree that the y value is the same? So what is the y value at this top point? That is the y coordinate of this point, right? What is the y coordinate at this point? Since the x coordinate of this point is x, because notice that is the distance x, so this point has an x coordinate of x, so the y coordinate must be 5x minus x squared, because this point happens to be on the parabola. So the y value is 5x minus x squared here, and we come all the way down to the line of revolution. What's the y value of the line of revolution? Hey, you got the equation here, y equals -1. So -1 is the y value of this bottom point. So R sub O is 5x minus x squared minus the -1. As simple as that. Now, in a similar way, if you want to get R sub I, because we are measuring vertically, we do top minus bottom. So the top point, by an explanation similar to the previous one, has a y value of x, because that's a point on the curve y equals x, and the bottom has a y value of -1. So we have x minus -1 is R sub I, which is x plus 1. Now it's all a matter of plug and chug. A is 0, 0 to 4, RO square is 5x minus x squared plus that stuff. As simple as that. I'm going to leave the integration itself to you. Okay. The next, problem 2. There we go. So problem 2. What? It looks the same. Kinda. For the most part, it looks the same. But the small difference is now the line of revolution is over here. Remember, the first order of business is to draw that representative rectangle. In this case, it's going to be vertical. The second order of business is to draw x and dx. And then we are going to decide, the next step is, we are going to decide whether we would use the shell method or the disk washer method. If you recall, Now, all that hinges on the relative orientation of the rectangle with the line of revolution. Here, the rectangle is parallel to the line of revolution, so that's going to be shell. And immediately identify the method. Be sure to clearly write shell method because that way both you and I would know which method you are applying. And the differential volume V is 2 pi r h t, like we saw just a bit ago, right? And if you want to get the total volume, you integrate 2 pi r h t from A to B. 2 and pi are constants, so they came out. And R and H, I'll show you what they are. T, at least, I'm sure you would agree, is dx. So this is 2 pi RH dx. Okay. What is R? If you recall, R is the distance from the line of revolution to the rectangle. Which point on the rectangle? Doesn't matter. As long as you are just going horizontally. Oh, yeah, I better say that. Hey, you said the distance from line of revolution to the rectangle, man. So I'm going to go across like that or at an angle. No, 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 don't do that. We want to measure the distance horizontally here because the line of revolution is vertical and the rectangle is vertical. When we say the distance from here to here, I mean the horizontal distance. Okay. So from the line of revolution to any point on the rectangle is perfectly fine. That is R. Exactly what it is, we'll figure that out in just a second. And what is H? H is the height of the rectangle. And because we are measuring vertically, we'll go top minus bottom. Top to bottom, we'll make sure that H is a positive quantity. Okay, I think we are ready with all the calculations. A is 0, B is 4. H, let's figure out H. H is the Y value there, which is 5x minus x squared, and minus the Y value here, which is x. As simple as that. As for the R we are measuring horizontally, right? So that means we need to figure out what the x value at this right side point is minus the x value at the left point. Please pay attention to that part. Because we are measuring R horizontally, we should take the x value at the right side point, and from that we need to subtract the x value at the left point. What is the x value at the right side point? Well, you're noticing that this is x. So the x value at the right side point is x. And the x value at the left hand point is, because this is line of revolution is x equals -1, is -1. So x minus -1 is R. And the next thing all you need to do is plug and chug. Plug all of these, evaluate the integral, you got the volume. Cool? Let me look at problem 3. What's the deal with this one? Well, it's pretty similar to the first one and the somewhat second one. The only difference is the line of revolution is above both the curves. Okay? Well, what do? Recall, first step, rectangle, vertical. Second step, x and dx. Third step, deciding which method to use. Rectangle is perpendicular to the line of revolution, so disk washer. Washer automatically means the formula for the volume is pi times rho square minus ri square times t. We need to figure out what r sub o and r sub I and t are in this case. R sub I is the distance from the line of revolution to the closest point on the rectangle. So that is R sub I. And r sub o is the distance from the line of revolution to the farthest point on the rectangle. So that's r sub o. Pretty much you're done. A0, B is 4. R sub o is the y value at the top point, top minus bottom. Please do not forget that. The y value at the top point, all of these points have a y value of 7 minus the y value along this line. Well, if we know the y value of that point, which is x, we know the y value everywhere along this line. So 7 minus x is r sub o. And r sub I is top minus bottom. Top is 7, has a y value of 7, and the bottom has a y value of 5x minus x squared. That's it. Plug and chug. So maybe a couple more problems. Now I put the line of revolution over here on this side. First order of business is rectangle, x and dx, deciding which method. Rectangle parallel to the line of revolution, so shell. Formula is 2 pi r h t. We need to figure out what is r, h, and t, and we are done pretty much. Okay. R is the distance from the line of revolution to the rectangle along the horizontal direction here. Okay. And h is the height of the rectangle, so that distance, and t is the dx. So let's do this. H is the y value there minus the y value here. So 5x minus x squared minus x. That's h. R is the x value at the right point minus the x value at the left point. So the x value here is 7 and the x value here is x. What? I thought the x value there is x plus dx, man. Yeah, but I said, what exactly is this x? X, it doesn't matter whether you're measuring it to the left edge of the thing, or you know what? Maybe I'll put it a different way. R is the distance from the line of revolution to any point on the rectangle, right? As long as you're measuring horizontally. So maybe instead of what I have shown in the figure, we could measure it all the way to the left edge. Wouldn't make any difference in the grand scheme of things. So assume that this was actually extended all the way there. So in that case, would you agree the right side value, x value is 7, and the left point x value is x? So 7 minus x should give you r. Cool. Plug and chug, you're done. Let me pick one last problem, which is slightly different figure altogether. All right. Remember, first thing, rectangle. Which way? Should the rectangle be horizontal or vertical? I'm sure you agree. A horizontal rectangle actually works better because a vertical rectangle, you would have to go through two different kinds of formulas for the height of the rectangle. So we will take the rectangle to be horizontal and we will integrate from bottom to top in this case. Immediately you need to draw y and dy. In the previous case, x and dx. This time it's y and dy. And we need to figure out what method, right? Because the rectangle is parallel to the line of revolution, shell. Shell 2 pi r h t. So what is r, what is h, what is t? If you figure that out, you are in business. R is the distance from the line of revolution to the rectangle. H is the width of the rectangle. Because we are measuring the h in a horizontal direction, I got the arrow pointing this way to indicate that you do the right point minus the left point. and just about done. Um, C is 0. What exactly is C here? The y value at the bottommost point, because we are integrating along the y direction, we need to pick for the interval, the bottom point of the interval is y equals 0, and the top part of the interval is y equals 1. So those are C and D. C is 0, D is 1. Or is the y value at this point, which is y, right? Y value at this point is the same as the y value at that point, which happens to be y, minus the y value here, which is -1 according to the line of evolution. So y minus -1 is r, which is y plus 1. And to get the height, x value here is square root of y, because this point is on this red curve. And x value here is y square minus 1. So square root of y minus the quantity y square minus 1 is our age. Plug and chug, you're done. That's it.